differential rate law for first order reaction is rate is equal to what? Rate is equal to minus d concentration of A upon dt equal to K into concentration of A at time t plus 0. Yes, this is the differential equation or differential rate law for first order reaction. Minus d concentration of A upon dt is equal to K into initial concentration At plus 0. If we write it in the y is equal to mx plus c form, then we have y is equal to mx form. This is the equation for the straight line. We can represent it in the straight line form. This is the equation in the form. This is equation in the form of y is equal to mx plus c. This equation is of straight line. If we plot concentration or rate versus concentration, final concentration. See here in the graph. In this graph, we have to represent the straight line. This equation is in the straight line form. Y is equal to mx plus c. Yes, in the rate versus, if we plot this graph, rate versus initial concentration, that is At. Rate versus concentration. It is the straight line. It looks like as. It is the straight line. Rate versus At. If we plot the graph, rate versus At, it is a straight line passing through the origin. If we plot rate versus final concentration, At, is a straight line passing through the origin, and in this equation the slope of this line is m, that is k. Therefore, from this equation we can calculate the slope of the reaction. Slope of this reaction is k, because m represents the value of k, that is value of slope. This is the first graphical representation for first order reaction. First form of graphical representation of first order reactions. Yes, if we plot graph against rate versus in final concentration, it is a straight line passing through the origin having the slope k, which is in the straight line form, that is y is equal to mx plus c. Y is represented by minus dA upon dt. K is represented by slope, and final concentration or At represented by x, that is intercept on y axis, and 0 represent c. Yes, this is the rate law. K is equal to 2.303 upon T log to the base 10 initial concentration upon final concentration, or A0 upon 80. We know integrated rate law. Yes, integrated rate law is K is equal to 2.303 log to the base 10 is 0.80. We have to convert it into log to the base 10 80. We have to convert for, or on rearranging this equation, we have to rearranging equation KT over here 2.303 KT upon 2.303 equal to log to the base 10 initial concentration or A0 minus log to the base 10 final concentration, that means 80. Yes, we have to calculate the graphical representation for log to the base 10 80. Therefore, we write it in the this side log to the base 10 initial concentration 80 is equal to minus K upon 2.303 into T. This will be plus log to the base 10 of initial concentration. That means Z into Y is equal to mx plus C form. Here it is x and it is a C. This is the straight line equation. If we plot log to the base 10 A0 versus 80, A0 versus 80, we have the graph as it looks like as here. If we plot initial concentration upon log to the base 10 initial concentration upon final concentration, we have to draw the straight line because we get the straight line from equation y is equal to mx plus c. So we have to plot the straight line. We have to plot the straight line on y-axis log to the base 10 A0 upon 80 versus time. It is a straight line, but do not passing through the origin. This straight line do not pass through the origin. It looks like as if we plot log of A0 upon 80 versus time. It is a straight line, but do not passing through the origin because C do not have the value of 0. Do not have the value of 0. From this equation, we can conclude that the slope of this line or slope of this integrated rate law equation is minus K. Having M is the slope, having the value minus K upon 2.303. It is the slope of that straight line, and the y-axis intercept as log to the base 10 of A0. Therefore, we can write slope of the equation is M having the value minus K upon 2.303. Yes, minus K upon 2.303 is the slope of that equation, and y-axis intercept y-axis. I write it in this side. Y-axis intercept is log to the base 10 of initial concentration A0. Rate log and log to the base 10 in the form of A0 upon 80 equal to K upon 2.303 into T. Log to the base 10 A0 upon 80 equal to K upon 2.303 into T. We write it in the y is equal to mx form. This represent as y log to the base 10 A0 upon 80 represent y. K upon 2.303 represent the m, that is slope of that reaction, slope of the straight line, and this represent the x. This is the equation of straight line. Equation of straight line of the form y is equal to mx. We plot the graph of log to the base 10 initial concentration upon final concentration A0 upon 80 versus time. Here we have to draw the graph for the log to the base 10 A0 upon 80 initial concentration upon final concentration. Y-axis, I write it in the log to the base 10 A0 upon 80 versus time. X-axis, I draw it in the time. This is the equation in the form of y is equal to mx. Equation is in the form of y is equal to mx. This is also the equation of straight line, but it is passing through the origin because y is equal to mx plus c. Here is no c having the value of 0. Therefore, I do not write the value of c, which is a 0. Therefore, it is the equation for the straight line which is passing through the origin. The graph is look like as log to the base 10 A0 versus time passing through the origin. Slope of this straight line equation is K upon 2.303. The second form having the slope minus K upon 2.303, and third form having the slope K upon 2.303. This is twice H2O2, means hydrogen peroxide liquid gives twice H2O, 2 molecules of water plus oxygen gas. The rate for this equation, for this reaction, the rate can be given by rate is equal to rate constant K into reactant concentration, that is H2O2. Reactant concentration, that is hydrogen peroxide. This is the first example for the first order reaction. Second example, 2 molecules of N2O5 group, nitrogen oxide gas, dioxide gas plus O2 gas. For this, we have to write the rate of this reaction K into concentration of reactor or reactor concentration. It may be K into N2O5, rate constant into En25.